So our next speaker is Jill Haszard. So Jill's an associate professor. She's been with the university since 2013, graduating with a PhD in human nutrition, but she's also a biostatistician. So she has expertise in a wide variety of study designs, including RCTs, crossover trials, etc. So she collaborates with many health researchers and plays a key role in designing projects and analysing data.
Thank you. Well, we need to talk about sleep more. As a biostatistician, I'm mostly focused on the design, analysis and interpretation of studies. But in particular, I'm interested in trial designs. So today I'm going to share with you a few of the things I've learned from designing sleep intervention trials in children from a biostatistician's perspective. So it's important that when we do research, we don't lose sight of the big picture. It's easy to get lost in the details. So I want to take a moment to remind ourselves of the purpose of health research, which is what we're all doing here today, and that is to improve health. In particular, it's to improve health in those who are vulnerable to poor health. So there are numerous studies that have linked sleep and health, but many of these are observational studies. The problem with these studies is that they're likely to be highly confounded and we don't get a good understanding of the direction of the relationship. Does the sleep influence the health, or does the health influence the sleep? Or are sleep and health unrelated except through confounding variables such as household environment? It's difficult to get a good understanding of these dynamics with observational data. If we want to improve health, sleep might be an effective target. But first we need to know if sleep affects health, how it affects health, and how to target sleep to improve health. And we're unlikely to be able to answer these questions with observational studies, no matter how large they are. So we need trials. And there's a whole suite of different types of randomised trials, and I've listed some examples here today that I'll be referring to. So first I'll start with the DREAM study, which you've already heard a bit about. Many studies have shown that short sleep is related to obesity in children, but why? How would short sleep result in excessive weight gain? Is there more likely to be an energy imbalance when children are tired, or is it simply down to confounding? There was very little experimental evidence that had explored this question, so we designed a randomised crossover trial to answer it. And we decided to focus on mild sleep deprivation rather than more extreme versions of sleep deprivation, because this is likely to be the kind of sleep deficit that exists in many of our children currently, a silent risk factor, if you will. So to answer our question, we needed to induce a state of mild sleep deprivation and compare it to a state of no sleep deprivation. And this is where the problem lies. According to the literature, many of our child participants were likely to be experiencing mild sleep deprivation already, so their usual sleep couldn't act as the comparison or control condition. So the control condition in DREAM was equally as important as the active condition. We had 2 intervention weeks, as you've heard. One was a week of sleep extension, where the child went to bed an hour earlier than usual every night, but kept the wake time the same. This would effectively remove any current sleep deficit, and indeed 68% of our sample increased their sleep over this week simply by going to bed an hour earlier. The sleep restriction week required the child to go to bed an hour later than usual, inducing a sleep difference between the 2 conditions so that we had data from a week of mild sleep deprivation and could compare it to a week of no mild sleep deprivation. And we had some exciting results, as you've seen, but it wasn't all smooth sailing with getting the DREAM study published. With all 4 of our results publications so far, we've had requests for us to compare the sleep restriction condition to the usual sleep, rather than the extended sleep condition. But this wasn't our research question. Comparing to usual sleep isn't a useful comparison. It doesn't have a pathway to improving health, and it doesn't give us insight to the impact of mild sleep deprivation. So from a crossover trial to a parallel trial, The POI study was an effectiveness trial. It was actually also a factorial trial, but I'm only going to focus on one of the interventions, which was a brief sleep intervention in early infancy to reduce excessive weight gain in 2-year-olds. And this showed significantly lower BMI Z-score and significantly lower odds of obesity in the 2-year-olds that received the sleep intervention compared to those who did not. However, what we don't know is why a brief intervention with new mothers was so effective at reducing obesity. We also didn't know for whom it was most effective. These are questions that can be explored with mediation and moderation analyses. These types of analyses are recommended to enhance our understanding of treatment trials and should be treated as hypothesis generating, not hypothesis testing. So while we put our POI participants through a lot of different assessments at various times throughout the study, we did not identify any mediators. While we found that the sleep intervention did result in improved sleep, as well as improved maternal depression, none of these explained the effect on BMI Z-score or obesity, and so were not mediators. However, we didn't take any robust measures of diet or feeding over this time, which would have been strong contenders to be mediators. Moderation analyses are tricky to examine appropriately because these are essentially subgroup analyses, so the sample sizes can be small and unreliable. But as these are exploratory, hypothesis-generating analyses, we worry less about statistical significance and more on the direction and strength of effect. I like to present moderation analyses as forest plots, where at the top you can see the overall effect of the sleep intervention on BMI Z-score, significantly lower. We can also see that the effect was pretty similar by sex and by maternal education. However, while the intervention was effective in European babies, it doesn't look to be so effective in Māori babies. These results are useful to us. However, they're only exploratory and therefore are difficult to get published, which is probably why we don't see so many of them. Reviewers love their p-values. So I encourage researchers to persevere with trying to understand the mechanisms of their trials, of their interventions, and even consider pre-planning for some of these types of analyses in their protocols. So this leads me to Moemoeā, which was a Māori-led intervention trial in infants, where mātauranga Māori was used to develop an intervention to improve sleep in infancy. This was woven together with a Western science method known as MOST, the multi-phase optimization strategy. The MOST framework includes a factorial trial that examines the effectiveness of each component of an intervention to find the most effective combination of components to improve sleep. The purpose of this is to focus on the elements of an intervention that actually work, rather than wasting resources on delivering unnecessarily complex multi-component interventions. The problem for us was that the factorial design from MOST separates out the intervention components, whereas Mātauranga Māori tells us that everything is connected and all things are interrelated. So these were two conflicting approaches when we came to design the intervention components. While this was a challenge, our team created 3 clearly distinct and important intervention components that were grounded in Te Ao Māori, and we have now completed our data collection phase. However, we learned that a factorial optimisation trial like this is probably not an appropriate design for interventions set in Te Ao Māori. This is an example where not only does the study design have to match the research question, it also has to suit the community that it aims to inform. So next, we're designing a cluster randomised control trial with an effectiveness implementation design where we'll be informed by the outcomes of Moemoeā and we'll work much more closely with the community to develop the intervention and the study design. Another trial that we're planning at the moment, which also requires careful consideration of the community, is our trial of later school starts for senior high school students. Allowing older teenagers to start school later may be the most effective way to improve sleep at an important age where their biological clock may be different to everyone else's. And improved sleep at this age could positively affect multiple aspects of life. But to design a trial to change the time that school starts means that we have to work closely with the school communities without losing sight of our research question. So we're looking at using a stepped wedge design where each school gets randomised to start later for senior students at a different term throughout the year. This design combines both within school and between school comparisons to allow us to estimate how effective this intervention is on multiple outcomes, but also meets the needs of the schools. So what are the future needs for my field of research? The future needs for my field of research and yours is more biostatisticians on the ground, and more biostatistical input into projects. Biostatisticians design studies that get funded. We train the next generation of researchers in good scientific practice, Rosie. And at the moment, we often find that nutritionists get taught statistics by nutritionists, and that psychologists get taught statistics by psychologists. But biostatistics isn't an add-on. It's a large and complex discipline and isn't taught with a flow diagram of statistical tests. Biostatisticians decrease research waste by designing studies that are more likely to get funded first time. We contribute to papers that are more likely to get published and in higher impact journals, and we produce high quality outputs that are meaningful and actually contribute to improving health. Thank you.